use the chain rule with the product rule. Alright, so folks, in this video we're going to be talking about how to use the chain rule with products and quotients. So we're first going to start off by finding the derivative of y equals x plus 1 to the fourth times 2x minus 1 cubed. Alright, so hopefully we can see here that we are going to have to use the product rule because we have x plus 1 to the fourth times 2x minus 1 cubed. So we'll identify x plus 1 to the fourth as our first function of our product, and we'll identify 2x minus 1 cubed as the second function. And then if we remember our product rule, we know that the product rule, dy over dx, is going to be equal to the derivative of our first function times our second function plus our first function times the derivative of our second function. So now we just need to figure out what the derivative of our first function and the derivative of our second function are going to be. So we'll do a little scratch work here on the side. So let's see. We know that our first function is x plus 4, mix up, x plus 1 to the fourth. So then to find the derivative of the first, we are going to have to use the chain rule because we have an inner function of x plus 1 and we have an outer function of a quantity to the fourth power. So chain rule says take the derivative of the outer function first. So this is going to become 4 times the quantity cubed. We're then going to throw the inner function back in, which is x plus 1, and then we're going to multiply by the derivative of the inside. The derivative of x is 1, the derivative of 1 is 0, 1 plus 0 is just 1, so therefore the derivative of our first function, which I need to put the notation for, is 4 times the quantity x plus 1 cubed. Alright, on to the second. So our second function we defined as the quantity 2x minus 1 cubed. And then when we come in and take the derivative, guess what? It's a chain rule. Who would have thought? Well, maybe because I put the title on here. But anyways, we do have the inside function of 2x minus 1, and then we have the outer function of the quantity cubed. So chain rule says take the derivative of the outside first, so we'll get 3 times the quantity squared. We'll throw that inside function back on the inside, which will be 2x minus 1, and then we're going to multiply by the derivative of the inside. The derivative of 2x is 2, the derivative of negative 1 is 0, so we're just left with 2. And then we can multiply this out. 2 times 3 is going to be 6 times the quantity 2x minus 1 squared. And now we can just throw all this together. So let's see, we said the derivative of our first function is 4 times x plus 1 cubed times the second function, which is 2x minus 1 cubed, plus our first function, which is which is x plus 1 to the fourth. And then we have times our derivative of the second, which is 6 times 2x minus 1 squared. Alright, so now we can just do a little bit of rearranging here to simplify this down. So we're going to get 4 times x plus 1 cubed times 2x minus 1 cubed plus 6 times x plus 1 to the fourth times 2x minus 1 squared. Alright, and there we have it. Product rule with the chain rule. However, Newton doesn't want you to stop here, because Newton's like, hey, factor it. It's like, no! So yeah, we have to factor this bad guy. So let's start off. Let's look at our two terms, and we do have two terms here, first term and second term. And we're going to look at the coefficients first. So we're going to think, all right, what do 4 and 6 both have in common? Well, 4 and 6 both have a 2 in common. And then let's take a look at the next set of factors. What do x plus 1 cubed and x plus 1 to the fourth have in common? Well, those are both going to have x plus 1 cubed in common. All right, and then, moving right along here, what does 2x minus 1 cubed and 2x minus 1 squared have in common? Well, those both have a 2x minus 1 squared in common. All right, so that means we can factor out 2 times the quantity x plus 1 cubed times the quantity 2x minus 1 squared. So what's left on the inside? Let's do it. So 2 times what gives us 4? Well, that's going to be 2. X plus 1 cubed times what gives us x plus 1 cubed? Well, that's just 1, so we don't need to put that in there. And then 2x minus 1 squared times what will give us 2x minus 1 cubed? That'll be 2x minus 1. Plus, and then start back over. 2 times what gives us 6? That'll be 3. And then x plus 1 cubed times what will give us x plus 1 to the 4th? That'll be x plus 1. And then 2x minus 1 squared. To get 2x minus 1 squared is 1, so we don't need to put it. All right, so we have factored, but we have to simplify. So put on your distributed pants, because boom, distribute, boom, boom, and boom. 4 for the price of 1. Let's simplify. So this is going to give us 2 times x plus 1 cubed times 2x minus 1, curse you, Newton, times 4x minus 2 plus 3x plus 3. And there's still more we can simplify, because we can combine like terms on the inside of those brackets. We're going to write this again. 2 times x plus 1 cubed times 2x minus 1 squared times the quantity 7x plus 1. Whew, done, done, done. Mic drop. Let's do it. All right, so there you go. This is the answer that Newton is going to want you to get. Want to look at another one? Well, you don't have a choice because this is a pre-recorded video, so let's move on. Our next example, we want to find the derivative of 3x squared times tangent of 4x. Now this one's going to be a little bit simpler, a little bit less work, because we have 3x squared, which is one term, times a trig function. So again, we do have multiplication here, so we will have to use the product rule. So let's see, we have our first function, which is 3x squared, and then our second function, tangent of 4x. Now let's see if we can do this all in one line. Let's not try to do any side work here. Let's take off the training wheels. So let's see, y prime is going to be, product rule says we take the derivative of the first term, and the derivative of the first term is going to be 6x. Then we multiply by the second term, tangent of 4x, a plus. Then we write the original first term, 3x squared, and then we take the derivative of the second term, which is tangent of 4x, and oh no. Tangent of 4x has an inner function. The inner function is 4x. So therefore, we're going to need the chain rule. Chain rule says take the derivative of the outside. The derivative of tangent is secant squared. Then we're going to leave the inside alone, so we're going to let that 4x chill out in there. Then we need to multiply by the derivative of 4x, which is 4. All right, so now we can simplify. So 6x times tangent of 4x, there's really nothing we can simplify there other than dropping the parentheses. Then on to the next term. 3x squared times secant squared of 4x times 4. Well, we can multiply the 3x squared and the 4 together to get 12x squared times secant squared of 4x. And yes, we could technically factor this term out. We could technically factor out a 6x, but that's not super useful. That's really not going to simplify much, which means Newton will accept it as is. All right, next example, we want to find the derivative of y equals 2 sine of 3x times cosine of 4x. And now, we are going to have to use the product rule here because we have multiplication, but we're also going to have to use the chain rule because we can see that we have insides to both of our sines and our cosine function. So for the product rule, we need to identify a first function, and we'll pull that 2 in with the sine of x to make our first function, sine of 3x. And then we'll make cosine of 4x our second function. And let's just do this as we go along. No training wheels. Two-wheeler bike. All right, so let's see. We will have dy over dx is equal to the derivative first. So we know when we take the derivative of a function with a coefficient, we can leave the coefficient alone. Then we take the derivative of the outside, which is sine. The derivative of sine is cosine. We leave the inside alone, and then we multiply by the derivative of the inside, and the derivative of 3x is 3. Then we're going to multiply by the second function, which is cosine of 4x, plus the first function, which is 2 sine of 3x. And then we need to multiply by the derivative of the second function. And the second function is going to require the chain rule. So we take the derivative of the outside first. Derivative of cosine is negative sine. We leave the inside alone. And then we have to multiply by the derivative of the inside. And the derivative of 4x is 4. All right, so calculus done. Move on to algebra to simplify. So in our first term, we can multiply the 2 by the 3. And that's going to give us 6 times cosine of 3x times cosine of 4x. And then in the next term here, we can multiply the 2 with the negative with the 4. And that's going to give us a negative 8 sine of 3x times sine of 4x. Alright, so now there's really nothing we can combine here. The cosine of 3x can't multiply with the cosine of 4x because the insides are different. And same thing with the sines. We can't combine the sines because the 3x and the 4x are different. So that means that this is simplified as much as it can be, and therefore we are done. Alright, this next derivative is going to require the quotient rule, so get ready. Because we all love the quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Woo! So, we can identify our functions. We can take the 4x minus 2 to the 4th power to be our top, and we can take the 1 minus 5x to the 5th power as our bottom function. And we can see here that chain rule is going to be required for both the top and bottom because there's an inner function and there's an outer function. So, let's get to work. So let's remember the quotient rule. So y prime is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Alright, so now we already identified what the top and what the bottom are going to be, so now we just need to find their derivative. So let's do a little bit of scratch work on the side here. Again, we said the top is going to be the quantity 4x minus 2 to the 4th. So when we take the derivative, we are going to have to use the chain rule, because we do have the inner function of 4x minus 2, and we have the outer function of the quantity to the 4th power. So we're going to have to do the chain rule here, which says take the derivative of the outside first. So I'll move the 4 to the front, subtract 1 from the exponent to get 3. Then we'll put the inside back in, 4x minus 2, and then we'll multiply by the derivative of the inside, and the derivative of 4x minus 2 is 4. And then we can simplify this. The 4 and the 4 becomes 16 times the quantity 4x minus 2 cubed. All right, bottom, you're up. Get on down. So we've already identified the bottom function as 1 minus 5x to the 5th. So therefore, the derivative of the bottom, oh, that's a double prime. We just want a single prime. And just like with the top, we are going to have an inner function of 1 minus 5x and an outer function of the quantity to the 5th power. So, chain rule says take the derivative of the 5th power first. So it's going to be 5 times the inside raised to the 4th. And our inside is 1 minus 5x. Then we have to multiply by the derivative of the inside, which ends up being negative 5. And then we can simplify this by multiplying the 5 and the negative 5 to give us a derivative of the bottom of negative 25 times 1 minus 5x to the 4th power. All right, let's throw everything into our rule. So let's see, the derivative at the top we said was 16 times 4x minus 2 cubed times the bottom, which is 1 minus 5x to the 5th, minus the top, which is the quantity 4x minus 2 to the 4th, times the derivative of the bottom, which is negative 25 times 1 minus 5x to the 4th. And that is all over the bottom, 1 minus 5x to the 5th squared. All right, well, sadly, we are going to have to simplify this some more. So the first thing we're going to do is we're going to look at this negative 25, bring it to the front, and multiply by that negative. So let's see, what's that going to give us? That's going to give us, I got to write this all over again. 16 times 4x minus 2 cubed times 1 minus 5x to the 5th plus 25 times 4x minus 2 to the 4th times 1 minus 5x to the 4th. And that's all going to be over, and let's see, 1 minus 5x to the 5th squared is going to be 1 minus 5x to the 10th, because the power of a power is multiplication. All right, oh my goodness, how are we going to simplify this? Well, the same way we did with the product rule. We're going to first check the coefficients. Do 16 and 25 have anything in common? And the answer is nope. All right, so what about 4x minus 2 cubed and 4x minus 2 to the 4th? And yeah, they do. They both have a 4x minus 2 cubed in them. And then moving on to the 1 minus 5x to the 5th and the 1 minus 5x to the 4th, they both have a 1 minus 5x to the 4th in them. Which means we're going to be left with, let's see, we didn't move anything with the 16. We took the 4x minus 2 cubed out, and then we took 4 of the 1 minus 5x out, leaving us with 1 minus 5x, plus then 25 times 4x minus 2. And that is all over 1 minus 5x to the 10th. Okay, so let's keep on chugging. Well, if we look carefully, we can see that we have a 1 minus 5x to the 4th power in the numerator as a factor, and we have a 1 minus 5x to the 10th in the denominator as a factor. So that means I can cancel out 4 of those. So this factor is just going to go away, and this 10 is going to become a 6. All right, well then, we are going to distribute the 16 in. We're going to distribute the 25 in. Good thing we have on our distribution pants. And what's left? We're going to have 4x minus 2 cubed times 16 minus 80x plus 100x minus 50. And that's all going to be over the quantity 1 minus 5x to the 6th. And we are almost finished because now we can simplify the inside. So let's just draw that over here because I ran out of room. So let's see, we're going to get 4x minus 2 cubed times 20x minus, what's that going to be, 34, all over the quantity 1 minus 5x to the 6th. And finally, we have our derivative. Quick, take a quick water break. All right, rehydrated, let's go. And now the last example we have is a little bit of a doozy. Because we want to find the derivative of the quantity negative 2x minus 1 over negative 4x plus 1 to the 5th. So this is opposite from what we've done before, because before we've had the quotient rule on the outside, and the chain rule on the inside. But in this problem, we've got the chain rule on the outside and the quotient rule on the inside. So, again, we can see that the inside function is negative 2x minus 1 over negative 4x plus 1. I don't think the underlining is really showing that, so let's just put that in a box to show that's the inner function. And then the outer function is going to be the quantity to the 5th power. So, let's do the derivative. Y prime is going to be equal to, chain rule says we take the derivative of the outside first. So we're going to take the derivative of the 5th power. So that's going to be 5 times the inside to the 4th power. Then we're going to put the inside back on the inside. Then we need to multiply by the derivative of the inside. And the derivative of the inside is going to require the quotient rule. Quotient rule says take the derivative of the top. So the derivative of negative 2x minus 1 is negative 2. Multiply that by the bottom, minus the top, negative 2x minus 1, times the derivative of the bottom. And the derivative of negative 4x plus 1 is negative 4. And that is all over the denominator, negative 4x plus 1 squared. Whew. All right, so let's keep on working. So looking at our quotient rule expression here, we can distribute the negative 2 in, and we can distribute, let's see, we'll distribute the negative 4 in first. And what do we have? Well, that's going to give us 5 times the quantity of negative 2x minus 1 over negative 4x plus 1 to the 4th times 8x minus 2 minus 8x plus 4 all over the quantity negative 4x plus 1 squared. All right, now we can take this negative and distribute it in. So that's going to give us 5 times the quantity of negative 2x minus 1 over negative 4x plus 1 raised to the 4th times 8x minus 2 minus 8x minus 4 all over the quantity negative 4x plus 1 squared. All right, now if you have to get another piece of paper, please feel free to go get it because this is a lot of work, and I assume you've run out of paper by now. All right, but continuing on our journey, positive 8x and negative 8x will cancel out. So we're going to be left with 5 times the quantity negative 2x minus 1 over negative 4x plus 1. I can't believe I'm writing that for a 4th time now. To the 4th times the quantity, let's see, negative 2 minus 4 is negative 6 over the quantity negative 4x plus 1 quantity squared. Whew! I guess we are finished. Well, not quite, because there's some stuff we can still do to simplify. Oh, man. So yes, there's still some simplification we can do. The first simplification is that our second expression here doesn't have an exponent. It's a single expression, which means we can take this 5 in the front and multiply it by the negative 6 over negative 4x plus 1 squared. And when we do that, we are going to get negative 30 over the quantity negative 4x plus 1 squared times. Well, if we look back at the first term, negative 2x minus 1 over negative 4x plus 1 to the 4th. We know based on some of our exponential properties that we can break that apart to be the numerator to the 4th power over the denominator to the 4th power. And when we do that, we notice something strange that happened. Well, not really strange, coincidental. That the denominator of our first fraction has the same base as the denominator of our second fraction, which means we can multiply those together, and that is going to give us negative 30 times negative 2x minus 1 to the 4th all over the quantity negative 4x plus 1 to the 6th. Because when we multiply the bases, we add the exponents, and now we are finally at a Newton acceptable answer. Whew! Boy, don't I love product and quotient rule with chain rule. Yes, you do. Alright folks, and that is it. That is the end of using the chain rule with the product and quotient rules.